So I wanted to first start out with just a more positive spin on the future of electric vehicles and refer you to a study that was done in 2008 by Dan Kimmin and Alex Farrow at UC Berkeley, where what they did was essentially an analysis of how many plug-in hybrid vehicles could be charged in California. They estimated that in the existing infrastructure on the order of about 1 million could be charged. They used the EPRI plug-in hybrid vehicle characteristics. The other, I think, optimistic thing is that if you go to any house, at least to casual empiricist, almost any house in California with a solar panel on the roof, you'll also see a plug-in of a Prius or other hybrid sitting out front. So in that sense, I even think the correlation's working in your favor to allow this sort of charging to take place. So I think the infrastructure is certainly there. I certainly agree with the regulatory barriers, but I think those are, being solved and certainly will be solved by the time the cars come. So that's my brief editorial response to stimulate discussion. So what I want to talk about here is just what I've outlined here. In the interest of time, I'll just give the talk. So the first thing that I wanted to point out is looking at the consumption of energy. And this is all in BTUs. So in other words, we've converted everything to the essence that we're interested in. The thing I want you to get about the first diagram is notice wood ramps up, wood ramps down, coal ramps up, coal sort of ramps down. And what's happening? Well, what's happening is we're replacing higher value sources of heat, more flexible sources of heat, with, in other words, we're replacing less flexible with more flexible sources of heat. And that's going to be a theme that I want to reiterate through the talk. The other is just to show you that the energy consumption per capita, at least in the United States, is flat, if not declining. The other is to say that the energy content of $1 GDP is also declining. So in other words, we're certainly getting less energy intensive. The bad news is most of that energy intensity, as I'm sure you all know, is going to China. And they burn coal very intensively. But that's another talk. The next is just to show you the prices of fossil fuels. And here what we've done again is we've broken it out by dollars per BTU in real terms. Okay, so this is $2,000 in dollars per million BTU. And consistent with what I was telling you before, the price of crude oil consistently is higher than the price of natural gas, is consistently higher than the price of coal. Why is this? Well, essentially it reflects the fact that the quality of a BTU, the flexibility of a BTU of oil is significantly higher than the quality of a BTU from natural gas or from coal. But there's an important caveat, and the important caveat is what I've written in the middle of the page here, which is capital investments are what allow other fossil fuels to be used in the same manner. So think of it as capital investments, it allows BTU arbitrage. In other words, so if you notice that towards the latter part of the 2000s, we were getting lots of investments in things like natural gas-fired buses, power plants, et cetera, to essentially exploit that BTU arbitrage between oil and natural gas. Now, true, the price of oil blew out, and so that BTU arbitrage, but investments are again taking place to essentially exploit that BTU arbitrage. The good news with coal is we also have this BTU arbitrage that's possible. And one of the puzzles that we're going to talk about towards the end here is why is that BTU arbitrage not taking place with respect to coal? And the answer is going to be climate policy uncertainty, as we'll discuss at the end. Okay, so this just shows you the price of oil. The only point that I wanted to show here is lots of fluctuations in the price of oil and really hard to forecast. Largely because you can see there's what was forecast, there's what actually happened. Why is there so much volatility in the prices of fossil fuels? That just summarizes what happened. Is it because we're running out of fossil fuels? My answer would be no. And the simple idea here is reserves. What is happening with reserves? And the important thing with reserves is it's a recoverable at existing technology at a pre-specified price. So the nice thing is that people innovate. People are always searching for better ways to do things. And this is occurring in all parts of the economy, but also in the case of fossil fuels. And so we're constantly trying to figure out better ways to extract those things. And the basic point that was made by Maury Edelman, who's an energy economist at MIT working in the oil sector, is essentially his argument is, look, the amount of fossil fuel in the earth is largely irrelevant. What matters is the economics behind finding and developing versus what you think you can sell it for. And if you can't sell it for what it costs you to find it and develop it, then you're going to leave it in the ground. Okay? And so really what's in the ground is largely irrelevant, but technological change and prices are what's going to determine what you're going to leave in the ground and when you're going to take it out of the ground. Okay? And so his point is, and I think it's exactly right, is that the ultimate reserves are based on things that we just don't know. I mean, one of the things that's quite clear is even 3 to 5 years ahead, we have no idea what the technologies are going to be. My favorite example of this is essentially unconventional natural gas reserves. Less than about 5 years ago, the prognosis was we're running out of natural gas in North America. We need to develop a liquefied natural gas industry in the United States. That's the key to the future. Guess what? Unconventional natural gas reserves came, and the price of natural gas caved, roughly from about $8 per million BTU to currently it's running about $3 to $4 per million BTU. So, recently technology has been winning. I mean, where it's a constant, as I said, competition between technological change and depletion at existing technologies. And recently, as I say, technological change appears to be winning. Another win has been deep water drilling, the ability to essentially go out there and drill in places that literally weren't possible, even five years ago, and significant deep water discoveries have been made. So, this is just to tell you don't bet against innovation. This is a famous bet, at least among economists, because we like beating scientists, is essentially between an economist and a scientist. And the idea was, Julian Simon said to Paul Ehrlich, look, you pick the commodities, and if what's true is if the price of the commodity basket you pick, 10 years from now, deflated by the amount that the government's inflated the price of a dollar bill, is higher in 1990, I'll pay you the difference. If it's less, you'll pay me the difference. Well, Ehrlich lost the bet and essentially paid $576 to Simon. So thus far, technology has been winning. Now, will it continue? I don't know. I certainly hope so. That's why I'm at Stanford training really smart students to go do this.